Dear student, in the last video we discussed about combination logic circuits. What are the steps involved to designing of your combination logic circuits, and we just brief on the simple example to implementing or designing the combination logic circuit. Let's go with the next concept of switching function or Boolean function. So in this, what we going to discuss in any Boolean equation, how we can represent into a switching equation or a Boolean function. Okay, so the concept is switching function. So let me take any simple example. Y is equal to a bar bc plus a b bar c. This is one Boolean equation. Here we called all the variables. So variables a, b, c we have. All three variables we called as literals. Okay, so here this is a product term and this is your sum term as we discussed. So this is in the form of SOP form, that is sum of product. So in sum of product, all the literals are we represented in min term. Min term represents as logic 1. Let me take one more example. Y is equal to a bar plus b plus c into a plus, let's say, b bar plus c. Here also these are all we called as the literals. Here this is your sum term and this is your product term. So the totally we call it as POS, that is product of sum. So here all these literals are called as max term. So here the max term represent as logic 0. So this is the concept what we are discussing. So that means that the literal are arranged in two form. One is SOP form and another one is POS form. That is SOP means sum of product form and product of sum term. The concept is canonical form. Or also we call it as standard, SOP and POS form. So let me function y, whatever the output, the variable ABC, let's say ABC plus a bar BC plus AB bar C. This is, as we know, that this is SOP form, sum of product form. In this expression, that means in the SOP expression contains all the literals, then this SOP form is known as standard or canonical SOP form. See here in the function we have the three variables. All the terms, that is this is one term, this is one term, this is one term. consisting all the literal, then this equation is known as standard or canonical SOP form, that is sum of product form. Similarly, if you have ABC, let's say A plus B bar plus C into A bar plus B plus C bar. Let's say this is the equation is in POS form. So here also we have the three variables, all the term consisting of all the literal, then this expression is known as standard canonical POS form. Okay, so as we know that in SOP form it is represented the literal in the min term, and POS form the literal represented as in the max term. Let me have simple example to converting into standard canonical form. So take the example f of ABC is equal to AC plus AB plus BC. Here this equation, it is not in standard or canonical SOP form, because here in this term all literal are not present. So first step what we are going to do is step number 1. We find the missing literal in each term. So here missing literals are B, here missing literals are C, here missing literals are A. Then step 2, find the product term which missing literal plus complement of this. Like we know that A plus A bar is equal to 1, as we know in the Boolean equation. So same way here get the complemented form with the missing literals. Like AC into, we have the missing literal B plus B bar plus AB into C plus C bar plus BC into A plus A bar. That will be the same. Next, third step is multiply. So as usual we'll write it in the arranging form ABC plus A B bar C ACB, that is I am written as in the ordering form, plus similarly ABC plus AB, that is C bar, plus here ABC plus A bar BC. So whatever the repeated term, we cancel the repeated term here, we retain the only one term. So like we have ABC, the final expression is ABC plus A B bar C plus A B C bar plus A bar BC. So this is your standard SOP form or canonical SOP form. This is how we need to convert into the standard SOP form. Let me have one more example. Let's say same way we'll take one more example. Example 2. We have f of ABC is equal to A plus B into B plus C into A plus C. This is in the form of past form, but this is not in canonical form. So same step number 1, find the missing literal. Here it is missing literal is C, here is A, here is B. But here as usual we know that A into A bar is equal to 0. It is a product form. So we'll implement the same thing. The second step is and with what you're supposed to do, A plus B plus of that ORing with your A plus A bar. Before we did it in the AND operation, here we did it with the OR operation. Let me see that how we are supposed to do here. See, A plus B plus OR with the complemented form C into C bar into B plus C plus missing literal is A into A bar into A plus C ORed with B into B bar, because this will be 0. 0 with any odd with number will get the same number. Now same thing will add with all the multiplied number. So A plus B plus C into A plus B plus C bar A plus B plus C bar, this is over, into, I am ordering this, A plus B plus C into A bar plus B plus C into A plus B plus C into A plus B bar plus C. Remove the repeated terms, retain any one of this. So we will get the expression as A plus B plus C into A plus B plus C bar into A bar plus B plus C into A plus B bar plus C. So here it is standard or canonical pause form. So in the examination they are going to giving the this kind of expression. You need to convert it into standard canonical or pause form or standard canonical sub form. Any one of the method they are going to be asking. The next important concept is generation of switching equation. We need to generate the switching equation. Switching equation. How to generate the switching equation? Let me take the 3 variable equation here, the combination. Let me take A, B, C, 3 variables, and we have the min term here, and here we write the max term. Min term I am representing small m, max term representing capital M. So let me take the combinations for all the variable 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So this is the combinations. So we'll write the expression for each the variable as a minterm, considering as logic 1 here. So this is all zeros. So this is A bar, B bar, C bar. So this is we call it as M0. And similarly maxterm we can call it as logic 0 here, considering A plus B plus C. This is we call it as M0. Similarly A bar, B bar, C, here this is we call it as M1. A plus B plus C bar we call it as M1 in maxterm equation. So this is capital M. Similarly A bar, B, C bar, that is M2. A bar, B, C, M3. A, B bar, C bar, that is M4. A, B bar, C, M5. A, B, C bar, that is M6. A, B, C, it is M7. It is all in the midterm equation. We'll write it as maxterm equation. A plus B bar plus C, that is M2. Next A plus B bar plus C bar, that is M3. Then A bar plus B plus C, that is M4. A bar plus B plus C bar, that is M5. A bar plus B bar plus C, M6. A bar plus B bar plus C bar, that is M7. So this is your generation of a switching equation. So here each individual term is standard sub form. It should be in the standard sub form. Okay, and this should be, it is in the standard pass form. Then only we can easily write the switching equation. We'll take the simple example how to convert this one into switching equation. Let's say example f of ABC is equal to A bar, B bar, C bar, let's say A bar, B bar, C plus A bar, B, C bar plus A, B, C bar. First we need to check this equation is in standard form. Yes. Which form standard in this? It is standard or canonical sub form. So let's say here it is represented as 0, 0, 0, it is M0. 0, 0, 1, this is M1. 0, 1, 0, it is M2. 1, 1, 0, this is 4 plus 2, M6. So remember the sum of product form we represented as f of ABC is equal to summation, that is it represents the sub. Summation indicates that it is the sub form, that is M of, what are the minterm? 0, 1, 2, 6. This is the switching terms. Switching minterms. This is in sub form. Similarly, we'll take the pass equation one example. Then we can understand that. Let's say second example, f of ABC is equal to A plus B plus C bar, let's say, and next we into A plus B bar plus C. Next, let's say C bar into A plus B bar plus C. We'll take one simple example. Yes, first check this expression, it is in the standard or canonical past form. Yes, it is canonical past form. Let me write the max term number. So here it is considering zeros. So it is, instead of 1, it is 0, 0, 1. So it is M1. So this is 0, 1, 1. It is M3. This is 1, 1, 0. So it is M6. So here f of ABC, it is in the past form, that is a product of sum. We represent it as pi capital M of 1, 3, 6. So pi indicates that it is past form. Okay, so this is how we can represent the Boolean expression in the form of switching equation. Hopes you understand for the switching equation of Boolean equation, how we can represent in the SOP as well as POS. Those are in the canonical form. Thank you very much.